And okay, perfect. It's working. So today, as I promised, we will start IUPAC nomenclature, and like in previous lessons, we no needs to be prepared. This will be a short lesson. We not discuss deep topics, just major, most important, most basic topics. So at first, we will start with what we must memorize. It's this table. This table, it's what you must memorize, literally memorize. These words, these numbers, methane, ethane, propane, alkane, etc. If someone know Greeks, they probably know from pent, it means 5, and not only Greek, by Latin. Pent 5, hex 6, hept 7. If someone know Italian, it's also help you. It's help you understand name of any compounds. So at first, it's these names. We must memorize alkanes because name of any compounds, it's modification of name alkanes. So if you have any structure, you name it, it's like this alkane with this and this and this and this difference. It's like if we're planning to describe building, we describe it like cubes with holes for windows, holes for doors, and big empty space for living rooms. And let's train. For example, we have this compound, for example. For example, we have 1, 2, 3, 4, 5 carbons, and we name this compound 1, 2, 3, 4. 4 carbon atoms. It's butane. If it's butane, it means roots must contain but. But we have also double bond, so butane. So butane, it's name of these compounds. For some compounds, we also must know functional groups, suffix and prefixes. And if we have double bond, it's alkane, suffix -n, alkene, -ine, double bond, triple bond, single bond. Each compounds have unique prefix. If we have OH group, it's ol. If CHO, al. If CO without hydrogen, it's on. It's if COOH, oic acid, for example, citric acid, methanoic acid, benzoic acid, and ester ethyl acetate, for example, it's using typically in cosmetics. So let's train. We have any compounds and we must name it. First, we need to find longest chain. Longest chain, I think it's longest chain. First one, longest chain. Find it. Find how we name compounds with chain like this. Because it's 4, it's but. It means root must contain but. Second, we find modification. It's not butane because we have these small groups outside, so we name it's like methane, but not methane. Because it's not methane, we name methane, it's CH4, methane, and CH3, it's methyl. So these compounds in position 1, in position 2, in position 2, methylbutane. So find longest chain, find modification, name all modification, and name groups of compounds. It's typically how it's work. Second options, for example, we name compound example, this one, big Cl, Cl, and like this. Very big compounds, very complicated compounds. So we can name it, again, find longest chain. I think this chain is longest. So how many atoms in longest chain? 1, 2, 3, 4, 5. In this case, 5. How we name compounds with 5 with 5 carbon atoms? According to this table, it's pentane. So first, roots must contain pent. Second step, modification. We have several modifications. It's not pentane. We have difference. We have these groups, and these groups. It's methyl. It's it's chloro. And because it's alkane, no needs to get many modifications, just this. So compounds we name as chloromethylpentane, but we have 2 chloro, so dichloromethylpentane, and we must count alphabetically at first. It's C, and second it's M. So compounds we name 3,3-dichloromethylpentane. Longest chain, modifications, and count modification. When we numerate modification, very important to make numbers as less as possible. So in this case, we can numerate from left to right and from right. Oh, wrong direction, because I'm not. So first, second, bad choice for numbering. So 1, 2, 3, 4, 5. 3,3-dichloro 2-methylpentane. Pentane because 5 carbon atom in longest chain. 3,3 because we have 2 chlorine atoms. Methyl because we have CH3 groups. 3,3-di because we have 2 chloride atoms in position 3, and 2 methyl because we have in positions 2 methyl groups. And at first it's chlorine because alphabetically after C letter it's before M letter. compounds with oxygen, for example, OH. I think everyone or most of you know these groups. We find longest chain. In longest chain we have groups at, because it's at, it's mean 2 carbon atoms. Second step, we must name all modification. We have OH. If we look on table, OH we name as all. So at ethanol. Ethanol, it's just normal alcohols it's using in drinks. Second options, for example, these alcohols in many countries, these alcohols use as replacement of ethanol because it's working by same way, but can be used as no one drink these compounds. So first, find longest chain. Longest chain. It's 3 carbon atoms. 3 carbon atoms, it's mean prop. Prop. Then find modification. Modification, it's OH. Position of OH, it's all. Position, it's 1, 2, 3, and it's propanol. So if we generalize all organic compounds names, we have same orders. For example, we have alkenes. Step 1, find longest chain, 5 atoms, it means pent. Second, find modification, it's these groups and double bond. These groups we name methyl. These groups we name N. And 1, 2, 3, 4, 5. We numerate this from left to right because in this case numbers of groups minimum, and compounds we name 2 methyl, 2 methyl pentane 2. 2 methyl pentane 2. We use highest order of groups we put in name in last position. Then we have orders pent, and in front of roots we have all other functional groups. So not all functional groups we put in front roots. We put in front roots all roots except highest order groups. In this case we have highest order groups. It's double bond N. Or in other position we have example OH. Finding number of carbon atoms in longest chain. 1, 2, 3, 4, 5, 6. 6, it's hex. So roots must be hex. Second, modification. We have these groups and these groups. It's methyl. It's all. And numerine. We numerate, we have two ways, from left to right and from right to left. OH groups have highest order, so we must numerate by way where OH group have minimum numbers. So 1, 2, 3, 4, 5, 6. 5 methyl hexan 3-ol. 5 methyl hexan 3-ol. So if we generalize, find longest chain, name longest chain, find modification, name modification, and put all modification alphabetically before roots except highest order groups. And highest order groups typically, if you have oxygen, you have highest priority than without oxygen. If you have double bond, it's more prioritized than triple bond, than single bonds, etc. So it's how it's work. I think it's not very hard. Today we just discuss simplest way. On the next lesson, I will discuss stereoisomers. In this case, we will discuss more complicated substance. Thank you for watching my lesson, especially someone who watching it live. I know now my equipment still not perfect, but I will try. And I promised next video will be much more fun. So thank you for visit again. Subscribe, share, and have a good weekends.